All right, in this lesson, we're going to talk about conditionals in Python, conditionals and flow control. Go ahead and launch a notebook. We've already seen conditionals a little bit, and that is the test that tests whether something is true or false. So, for example, a conditional is this statement. The equal sign is a Boolean operator that is double equals. So a single equals would be a variable assignment in Python. A double equals is a Boolean operator. And this whole line together is called a conditional statement. It's basically a test if something is true or false. So we've already seen the double equals. We'll go through several other ones. For example, there is the not equals, which is an exclamation point followed by an equal sign. Of course, 9 and 9 do equal each other, so if we evaluate that cell, we get false. But a separate example that proves that it's true. Right? 9 is not equal to 10. That is a true statement. There's also less than and greater than. There's also less than and equal to, less than or equal to. So in this case, that would evaluate to true because 9 is equal to 9. And likewise, there's greater than or equal to. Any of these statements can be negated by putting not in front of it, like so. And they can all be combined together with and or statements. So for example, we wanted to say, we've already seen that that is a true statement. So if we wanted to combine that and test whether two statements are true, so for example, is 9 less than or equal to 9 and 9 less than 10, that would evaluate to true because both things are true. However, if we were to change the second one to greater than, making the second statement evaluate to false, we would get true, false. So true and false is going to return false. Okay. There's also the or statement, which would return true if either statement is true. So 9 is equal to 9, we know that's true. 9 is greater than 10, we know that's false, but because the first one is true, this will return true. Okay. And these or and operations can be combined. So for example, we know this first statement evaluates to true. We could then add a third, condition that says and something like that. And if we wished, we could negate the whole statement like this. So what we'd like to do to create or control the flow of programs is we combine these conditional statements with something called an if statement. Every programming language has an if statement. In Python, the syntax is simply if something is true. For now, I'll just put in the Boolean variable, forcing it to be true. So if something is true, then what goes in the body of the if statement, I'll talk about exactly how the body is defined in a second. But if the body, what goes in the body is something like a print statement in this case. So if true, print this is true. Whatever is in the body of an if statement is indented over. So we could have multiple lines. For example, we could, in addition to printing, we could set the variable x equal to 10. So now, since this x is not spaced over, it's no longer the under the if statement. So this will run, if true, it will print this is true. It will also assign the variable x equal to 10, and then because I put, say, print x here, then we can see that it prints to the screen. However, if this were false, and I'll need to restart the kernel to force the variable x to be empty, not assigned. So if this is false, of course it's not going to print this is true. It's also not going to assign the variable x equal to 10, and so this print statement will have an error because x is undefined, and it does. So instead of actually putting in true or false, what we often do is, or almost always, is put a conditional statement there. So for example, we could say if 9 is greater than or equal to 9. Well, we know that's true. So this will evaluate to true. This statement will evaluate to true, causing what's in the body of the if statement to run. So it'll print it is true, and x will be assigned to 10. We can print x if we wish. Now, in most cases, we don't, there's no reason we can look at that and verify it's true, so there's no reason to have the computer test for it. Usually the case is that we have some variable whose value could be changing due to other factors. So in this case, I'll just call it variable equals to, I'll assign it to a value, say 10, and replace the initial 9 with that. So what this is saying is this variable, which we can change here, will be replaced there. So this will be saying if 10 is less than or equal to 9, which we know of course is false, then print x. Okay. Again, I'll need to restart the kernel because x has already been defined, and you'll see that this returns an error. Okay. So however, if I make variable 8, now this evaluates to true and it works again. Now we often don't want errors to occur if we make assignments. So it's usually the case that we'll have a so-called else block. So if this is true, do this, else do something else. And in this case, we'll just have it assign x to 9999. And this will never fail given given any variable, given any value of variable, right, var. So if I run this for that, or it's always going to run. It'll never produce an error. And in the event that it's false, it assigns x to 999. So we can also, so this is called if else. We can also have something called else if. So else if allows us to have another conditional statement. So in this case, if the first one is false, it will move on to the second one. So what we'll do here is we'll say we'll change it to this. So, and we're going to remove the print statement. I don't think we need that anymore. So in this case, this will be evaluated in the order that they're read as you go down the page. So if the first conditional statement, if variable is less than 9, x will be assigned to 9. If that becomes false, it'll test the next conditional statement in this elif block. So this will test if the variable is identically equal to 10, then set equal to 10. Otherwise, set x equal to 9999, and then print x, right? So of course, this is simple enough that we can just know what's going to happen up front, right? The variable's 100. The first one will be false, so we'll move on to the second one. The second will be false, so we'll move on to the else statement, and there's no test. This just occurs in the event that both of the other two are false. So if we run this, we'll have 999. However, if we change it to that, right, if variable, which is 8 in this case. 8 is less than 9, so x is assigned to 9. And the other parts of the if statement are not even run. If variable is identically equal to 10, in this case, the first conditional statement is false. The second one is true, so x is assigned to 10, and this thing exits. So it never goes to the else statement down here. And again, what we had in the beginning. All of these conditionals on each line can be replaced by something very complex. So again, it could have these multiple conditional statements, trues with ands or ors, negation operations, anything like that is also valid in these. It's good practice. It's not required in Python, but it's good practice to put parentheses around the conditional statement just so you can see exactly how it's evaluating. Particularly, this is important when you have multiple condition statements. So in this case, the parentheses force this first combination of OR to be evaluated before the AND operation. Also, it's good to know that these things actually short circuit. So in other words, if you have something that's true, if you have an if statement that's true, it will evaluate that and then exit the if statement. The other ones will not be evaluated. So if the variable is less than 9 is true, nothing else will be evaluated after that. Of course, in this case, it wouldn't change the answer, but you might have scenarios where it would be. For example, if the variable is less than 9, x is 9. However, if the variable is identically equal to 8, then x is equal to 8. Let's run that and see what happens. With an input variable of 7, right? So 7 is less than 9. X will be assigned to 9. Okay. However, if we change that to 8, now 8 is less than 9, which causes this first statement to be true. X will be assigned to 9, and the code will exit. So this statement that checks if the variable is identically equal to 8 will never be run because it's been short-circuited here. Okay. So that's just something to be aware of. If you want to do you'd have to come up with a more clever logic. For example, if you wanted anything less than 9 except identically 8 to be equal to 9, then what you'd have to do is say less than or equal to 7 or equal to 9, identically equal to 9, something like that, right? So this would say anything less than or equal to 7 or exactly 9 gets set to 9. And so in the case when this is 8, this would be false. This would be identically equal to 8. X would be assigned to 8, and the program would exit. However, if we make x large, something above 9, then we get the 9. So you can also nest if statements. So just to start something clear, we'll start something new. So we'll just say if true. Well, let's do something interesting. Let's just say if var, and var will set to either true or false in this case. So we'll just set it to true. So if var is equal to true, and then you can say if x, we'll have another variable called x. If x is less than 10. So in this case, and I just put the spaces in here for clarity. There's no requirement that there's spaces in the vertical rows, just for readability. So if var is true, then we'll go into this block, and in this case, we'll test to see if x is less than 10, we'll print x, and otherwise, we'll print x plus 100. However, if var is false, the program will just print exit. So in this case, if we execute it, because x is 9, which is less than 10, it prints x. However, if I make x 11, it's going to print 111. If I make var false, then it's just going to print exit. So through these combinations of if statements and conditional tests, we can create a lot of complexity in a program by flow control, essentially. So as variables change due to the output of other functions or calculations, the code can take a different path. You know, if something is true, take one path. If something is false, take another path. The best way, of course, to get used to these is through trial and practice. So we'll practice lots of these conditional statements.